Hello 8th graders. In this IXL video we're taking a look at assignment F12, which is called Evaluate Expressions Using Properties of Exponents. And what this is going to do is combine everything we had from F8, F9, F10, kind of put all those rules together into one assignment. So the first thing I'm going to show quickly is kind of our page 2, our keynotes that had these different properties. How do you multiply with exponents? How do you divide with exponents? How do you apply an exponent to another exponent? These are the rules we're going to be pulling and using here to evaluate different expressions. Alright, so the first one we see is following the multiplication rule. We see it says 4 squared times 4 squared, and that really is going to mean at the end of the day, let me get a better color, 4 to the power of 2 plus 2. If I use my property of multiplication, when I multiply the same base, I can just add those exponents. So this must be 4 to the power of 4. Other ways to think about this, you could have just done out 4 squared as 16. You could have done the other 4 squared as 16. And that's really what 4 to the 4th power means. You can do 4 squared, which is 16, another 4 squared, which is 16, and multiply 16 times 16. Now, I know that 16 times 16 is 256. There's a few ways you could get there. I would probably just use a whiteboard and write out 16 times 16, and then eventually you might get more familiar that 16 squared always makes 256. Alright, for our next one, this is where the properties start to become helpful. I don't actually want to do out 3 to the 5th power first. It's going to take a while to do 3 times 3 times 3 5 times. Instead, I want to use my property of exponents to simplify this first. I know if I'm dividing the same base, I can take the top exponent and subtract the bottom exponent. So I know 3 to the 5th divided by 3 squared must be the same thing as 3 to the 3rd power. And it's a lot easier for me to do 3 times 3 times 3 than to do 3 to the 5th, figure out 3 squared, and then end up doing whatever 3 to the 5th is divided by 9. That's a pain in the neck. But 3 to the 3rd power, 3 times 3 is 9, and then 9 times 3 is 27. So you see these properties make doing this math a lot easier. If I follow that property, all I need to really do here is 3 cubed, which is 27, and that saves me a lot of time from doing out 3 to the 5th power and dividing that by whatever 9 is. Same thing here, we don't want to do 5 times 5 times 5 times 5 times 5, because that's going to become a huge number. But if we follow our division rule, we know we can simply do the top exponent, the 5, minus the bottom exponent, and that tells us 5 to the 5th divided by 5 to the 3rd is just going to leave us, at the end of the day, with 5 squared. That base of 5 won't change. The power of 5 minus the power of 3 leaves us with 5 squared. And all of you know 5 squared, 5 times 5 is 25, and that's a lot easier to do than multiplying a bunch of 5s together. This is going to be 2 to the 4th power, which is 16. I want to keep things moving and find some different examples. Alright, so this one, and IXL is tricky sometimes. There's probably a couple ways to think about this. They gave us a different base here. So we have a few options. One of them, I would just do the math out here. I know 2 to the 4th power makes 16. And I know 4 to the 3rd power makes 64. And I would simplify this fraction. I know this is 16 times 2 is 32. 32 times 2 is 64. I do know this is 1/4. Now here's what IXL probably thinks you should be doing. I wouldn't do it this way, but they do see 4 to the 3rd power is really kind of the same thing, 4 to the 3rd power, is 2 times 2 to the 3rd power. Because 4 is 2 times 2, and then they know you could apply this, and this is really just 2 to the 6th power. It ends up being the same thing as 2 to the 6th power. So I don't know if they're hoping you see that, and if I see that it's 2 to the 4th power over 2 to the 6th power, then I could be doing 4 minus 6, which gives me 1 over 2 squared, or 2 to the negative 2nd power, and that would also be 1 over 4. But I think if they have different bases like this problem, I might be just switching them over to their 16 and 64 counterparts and knowing that's 1 over 4. But in green is probably how IXL expects you to think about this problem. Either way, definitely a little tougher. But we can do out the math up here by just multiplying those exponents out and simplifying the fraction. Or we could use some properties of exponents that I showed you down here to get the same answer of 1 over 4. And now go figure, IXL gave you a very tough one, and now they're just making you say, hey, 2 plus 2 is 4. So 3 squared times 3 squared is the same thing as 3 to the 4th. Or you could really just think of this as 9 times 9, because that's what 3 squared would give us. And 9 times 9 is 81, just like 3 to the 4th is 81. So our answer here is going to be 81, kind of no matter how I think about this problem. Two different ways. I should have used different colors, but two different ways we could see why this is 81. I think for this one you'd be okay. We see this as division, so I would encourage you right now to pause this, see if you could do this as an example from F9 really. But we'd be doing 9 minus 7, which is just 2. So this is really the same thing as 12 squared, and we see that's way easier than doing 12 to the 9th and 12 to the 7th, and then dividing those enormous huge numbers after you find them. I can just do 12 times 12, which is 144, and that is way easier than doing out the multiplication here. So hopefully those rules are starting to make sense to us. We think you're in good shape to do F12 on your own. And in the last few minutes, I'm going to skip ahead to some of the more challenging problems. So again, think you're good to shut the video off, to move forward. And now we'll see kind of, this one isn't even much tougher either. I'm going to skip ahead a little further to try to find tougher problems in here. Okay. And this one is tougher for sure. I'm curious what they want us doing. I think one thing they want us to see is that anything to the negative power means division. So I would really, as I'm thinking about this one, I'd be simplifying some things at first. I would leave 3 to the 4th in the numerator. But these negative exponents can be dragged in the denominator where division happens. And that automatically makes those negative exponents now become positive, because a negative exponent says to divide. So if I pull these down into the denominator, they're no longer negative exponents, they're positive. So this really just says 7 times 11 in the bottom, which is going to give us 77. And the top is 3 to the 4th power. We've seen that come up a few times. 3 squared is 9, so 3 to the 4th power is really, you could do 3 times 3 times 3, but I think of it as 9 times 9, because that would be 3 squared times 3 squared. And that gives me 81. And as I look here, 81 has factors of 1, 3, and 9. 77 has factors of 1, 7, and 11. They don't have any factors in common besides 1, so there's no way to simplify here. And this answer is just going to be 81 over 77. But you see towards the end here for IXL, they start just making you combine different things you know about math, and especially the ability to play with negative exponents, move their position in a fraction, turn them into positive exponents. So I'm going to do the same thing here with this one. When I see positive exponents multiplied with negative exponents, never mind, I changed my mind. Here I see they're all the same base, so I'm not even going to bother moving them to numerator or denominator. I'm going to first just add up all the exponents. I'm multiplying the same base, so I can do 6 plus negative 4 plus another negative 4 for that last exponent. And I know that negative 4 plus negative 4 just makes negative 8. When I add two negative numbers, I can just combine them to be a negative 8 in this case. And I know this really just means 6 minus 8. That's what 6 plus a negative 8 is. So that gives me a negative 2. So this has told me that my answer, when I do this stuff out, I'll switch to a different color, is going to be 11 to the power of negative 2. And here you see they're setting me up. They don't want me to use any negative exponents. So I'm going to have to do 1 over 11 squared. And you see they also say the word evaluate. I'm not going to be able to even leave this as 11 squared. They want me to actually do that out 11 times 11. So that gives me 121. Now, as you can see, when you get near the challenge zone, this just puts together a lot of different skills. I'm going to show one final one, but I really think that you just need to think carefully for each one when you're in the 70s and 80s and apply as many exponent rules as you understand. Here, I don't like the negative exponents when I'm asked to evaluate. I want to get them to positive exponents. That makes more sense to me. So I know that 3 to the negative first is the same thing as 1 over 3 to the first. And the divided by 10 squared is still going to be down there in the denominator. So this expression, 3 to the negative first over 10 squared, is the same thing as 1 over 3 to the first times 10 squared. And that's just 3 times 10 times 10, or 300. 10 squared is 100. 100 times 3 will be 300. So that's where the answer 1 over 300 comes from here. Again, this is a challenging assignment. Oh, one cool thing to show on the way out, you need to know the power of 0 is 1. And they're making you just kind of pull that power of 0 rule back into play here. Oh, that could be 1. 5 squared is 25. Cool, simple one to finish if you knew the power of 0 rule. But I do think this assignment's challenging, so if you have any questions, please do not hesitate to email me. That email is on the screen right now, and that is ddoherty3@bostonpublicschools.org. If you're a Mildred student with questions, please, as always, feel free to send me a GChat or a Google Hangout to that same email address. That's a bit quicker and easier if you want help right away, but I'll also see the emails if you send an email. Thank you for working hard on this tough assignment. Let me go ahead and delete that copyright of that C that's there and submit and show us yes, 1/25 was correct. And again, if you still have challenges on F12, please feel free to email me. Thanks for watching to the end of this very long video.